4.7 Law of Cosines. You're going to use the law of cosines to solve triangles that have side angle side and side side side. After you use law of cosines, then you can use the law of sines to find the remaining angles. So look at the formulas. You'll notice that whatever letter is in the front is also the same angle in the end, and then everything else is in between. So it's the same basic formula, you just move everything around. The front and the back should match, and the beginning kind of looks like Pythagorean theorem, and then minus 2 times that same thing. And it's for all of them. So just make sure you memorize one and just know the pattern. For side, 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 you're going to find the largest angle first with the law of cosines. Then you're going to find the next largest angle with the law of sines. So for number 1, solve if possible triangle ABC if your A equals 6, your B equals 8, your C equals 13. So I said that you always start with the largest one first. And since 13 is my largest side, that means that C is going to be my largest angle. So C squared equals A squared plus B squared minus 2AB cosine C. And then you're just going to do my favorite thing. You're going to plug and chug. 13 squared equals 6 squared plus 8 squared minus 2AB cosine C. Then your goal is to get this by itself. So that means these two have to move over first, and then this whole grouping has to move over. So when you move over 6 squared and 8 squared, and I'm going to do this all at one time to solve for C, 6 squared and 8 squared over, you're going to basically subtract them. 13 squared minus 6 squared minus 8 squared. And then you're dividing both sides by this quantity. Minus 2 times 6 times 8. That gets me my cosine C. And then, when you want to put it in the calculator, all you do is just do your inverse of that entire fraction. And that gives you angle C. So in this case, angle C is going to give me 135.9 degrees. That's close enough. I'm just going to say 136 degrees. Then from here, I want to find everything else. So then I'm just going to do my law of sines. So my 6 over my sine of A equals my 8 over my sine of B equals my C over my sine of 136. So the next angle that I want to find, and I'm going to do this on the next screen because there's not enough room on here. So I kind of said on the last screen, we're going to do 6 over sine of A, I just needed more space, equals 8 over sine of B, equals 13 over sine of 136. So I want to go for my next highest one. So I'm going to solve for B next. So we're going to cross multiply and divide. So my sine of B is going to be equal to 8 times sine of 136 over 13. And when I do second sine, I'm going to find that my angle B is 25.31 degrees, which means if you do 180 degrees minus 25.31 degrees minus the 136 that you got for angle C, you're going to get that angle A is 18.69 degrees. Okay, number 2 says solve if possible triangle ABC if A equals 3, B equals 8, C equals 4. So since B is my largest side, we're going to do B squared equals A squared plus C squared minus 2AC cosine B, which gives me 8 squared equals 3 squared plus 4 squared minus 2 times 3 times 4 cosine of B, which if you move this over here, divide by all of this, and take the inverse, you get that B equals cosine to the negative 1 of, start with the A squared, then once you move these over, this becomes a minus 3 squared and a minus 4 squared. And then you're dividing by this part. Okay. When you do that, you should see that you're going to get an error on, well, you won't get error, but yeah, you will get error on your computer or on your calculator because you're going to get a number greater than 1. So this makes no triangle. Okay, and let's go back to our days of geometry and think about this. If I have a side that has a length of 3, one that has a side of 4, and one that has a side of 8, one of your properties said the sum of two sides has to be greater than the third in all the combinations. And as you'll notice, 3 plus 4 is not greater than 8. So if you had seen that at the beginning, you would have realized that it's not going to make a triangle. Number 3, solve if possible triangle ABC if B equals 15, angle A equals 115, C equals 10. And obviously, since we have angle A, we're going to have to use the A squared in the beginning. We're just doing a lot of plugging and chugging things in. We'll do more word problems on your homework. So A squared equals B squared plus C squared minus 2BC cosine 115 degrees. And you'll notice that all of this is on one side. Just plug it into the calculator. And so remember, A squared is going to give you a number, and when you plug all that in, you're going to get 451.79. And then when I take the square root, I get 21.26 for my A. So once I do that, then I can use my law of sines to find everything else. 21.26 over my sine of 115 equals 15 over your sine of whatever angle B is equals 10 over whatever angle C is. So because we don't have a lot of space on here, I'm going to add another screen, so you might want to pause it now if you need to copy. Okay, to reiterate what we did in the last one, 21.26 over sine 115 equals 15 over sine of B equals 10 over sine of C. So again, I'm going to go for the next biggest angle, cross multiply and divide. So my B is going to be my inverse of 15 cross multiply, 15 times sine, 115 and over 21.26. So once you plug all of that in the calculator, you're going to get that angle B is 39.75 degrees, which means 180 minus my 39.75 degrees minus the 115 at the beginning is going to give me that my angle C is 25.25 degrees for that one. Okay, in a baseball game, a batter hits the ball to center field. So we have, home plate, first, second, third. A batter hits out to center field. This is center field. And throws the ball to third base. The distance from the center fielder to the home plate is 300 feet. Each of these is 90. And if you're going out to center fielder, that's going to make this angle in here 45 degrees. And I want to find out what the distance is from the center fielder to the third base. So we essentially have this triangle, X, 90, 45, and 300. However, because I want to find X, X goes with the 300, and the only thing, the X goes with the 45. If I want to do the 300, I'd have to get this side. If I want to do the 90, I'd have to have that angle. So since I don't have anything full that I can do, and this is side angle side, you have to use law of cosines to find it. I don't have one full complete fraction that I could use law of sines. So this is going to be x squared equals my two sides, my 90 squared plus my 300 squared minus my 2 times my 90 times my 300 times my cosine of 45, using my law of cosines. And when you add all that up and take a square root, you're going to get that your x is 244.78 feet for that length. Okay, last thing, Heron's formula. If you are given side, side, side to find the area of a triangle, you're going to use Heron's formula. First, you're going to find what's called the semi-perimeter. So the S stands for semi-perimeter. That is where you take half of A plus B plus C, and if the area is the square root of the semi-perimeter times the semi-perimeter minus A, semi-perimeter minus B, semi-perimeter minus C. So I'm going to find the semi-perimeter first, add them all up, add up all my sides, and divide by 2. That's going to give me a semi-perimeter of 72, which means my area is going to be square root of my 72, 72 minus 44, 72 minus 53, 72 minus 47. Again, a lot of plug and chug. You know, my favorite thing. You end up getting 978.57 feet squared for your area.